Hello, welcome back. Joe Reinhardt here, your instructor for the Cisco CCNP route training from TrainSignal. We are actually now going to be considering the more advanced aspects of BGP. And because there's quite a bit of information to be covered, we've actually divided this into two parts, a part 1 and part 2. So we'll begin with part 1 in this lesson. What we're going to cover in this particular lesson is first we're going to begin with BGP authentication, which is actually extremely simple to configure, even simpler than it is with IGPs. A little bit about default routes, general principles, and then specific ones to BGP, route summarization, route filtering, and then we'll wrap up with BGP peer groups. First, let's consider BGP authentication. We first want to understand what it is not, what it provides. Then we want to understand how to configure it, and then also how to verify that it's actually functional. So to begin with, BGP authentication, much like OSPF and EIGRP neighbor authentication, provides restriction from devices that can form neighbor relationships. And it also authenticates all messages sent between the configured peers. Remember, in BGP configuration, you talk about BGP neighbors, BGP peers, or BGP speakers, and they all mean essentially the same thing. The other thing that BGP authentication is able to do is, because of the authentication process, it can prevent denial of service type attacks. And as we've discovered previously, is there are certain things that authentication does not provide. It does not provide encryption of neighbor traffic. It does not provide any type of data privacy. To really be able to configure that would require IPsec to actually encrypt both sending and receiving of information. It would have to be configured per router, and it could be rather CPU intensive. But suffice it to say that authentication itself between neighbors does not provide any type of data privacy. Now, BGP authentication, there are a couple things about it that are distinctive. Much like EIGRP authentication, only MD5 is supported. There is no clear text password support. As with the other protocols that we've discussed, there is a pre-shared key configured on neighbors. Understand that it is case sensitive. Capital C Cisco and lowercase c Cisco are considered different keys, so keep that in mind. Another thing is it cannot contain a space after a number. It's just part of the logic of the way that it's written. So you can't have, for instance, BGP1 space anything. So keep that in mind. You can't do that within the key. And then you can use certain special characters, which we've listed out here before, and make sure you pay attention to those. And also understand that authentication is completed on a per neighbor basis. So in our diagram to the left, for example, R1 has to have 2 peering sessions and 2 password statements required to be able to have authentication between itself and the internet router and between router 1 and router 6, and it's the same conversely. So keep in mind it's on a per neighbor basis. Configuring BGP authentication is remarkably straightforward. As with a lot of other things, you enter router BGP configuration mode, router BGP, the autonomous system number. One of the things that you can do is make sure the neighbor relationship is already up and present. Otherwise, you might erroneously think you've done something wrong in authentication because the neighbor relationship isn't coming up. So do that with the neighbor, IP address, remote AS. This is actually the configuration statement, but you do show IP BGP neighbor, for example, and make sure that everything is there and that it's in the configuration. And then configure and apply the pre-shared key to the neighbor configuration. You recall the first thing you do is you put neighbor, peering address, remote AS, and the autonomous system number. Once that's done, and it's in the configuration, you can actually do a variety of other things, as we did in our basic lab, where you can change the timers or the source address or put in multi-hop. In this case, you put neighbor, the IP address that you're peering on, password, and then whatever the key is. And you do that for each neighbor relationship on both sides of the connection. Once you've done your configuration for BGP neighbor authentication, you need to make certain that everything is still up and functioning. So one of the things that you can do is use the command show IP BGP summary. It should show the active peers listed, and it should be in established mode, and you should see the prefixes that were being advertised and those sorts of things. You should not see active or idle or any of the other statements or something's been misconfigured. To get more detail, you can do show IP BGP neighbors, which, as you recall from our previous exercises, lists a multitude of different information elements for you to be able to understand what's going on with that neighbor relationship. And all the expected neighbors should actually appear. You can also do debug IP BGP and then the IP address and then updates to display the different neighbor exchanges that are going on if you want to do that for troubleshooting purposes. And then always make sure you set your NTP, Network Time Protocol, so that when you're looking at different syslog entries, you'll understand that everything's synchronized. So, because if it says March 1st on one and February 3rd on the other, and the time signatures are completely different, it's going to be really hard to correlate data. Another topic that we covered for other protocols has to do with default routing. Default routing, of course, has several aspects. We need to make sure we understand what default routing is, what it does, how to configure default routing, and then how to verify it specifically with respect to the BGP protocol. To begin with, as we've stated previously, you have to understand default routing. The purposes for a default route are various. It can help you with host routing, if you remember. In host routing, there was the logic of checking to see if something is on the same network, and if it's not, it would go to the default gateway. Very simple routing, but it also applies to larger routing as well. So host routing, it usually points to the internet connection, one or more internet connections, and for very simple networks, stub networks, it makes routing exceptionally simple. And if you recall, the mathematical significance of the default route is it's the most broad representation, essentially saying all routes. So if you remember the principle of longest match means that the most specific route in the routing table is going to be the one that IP routing is going to select. So a default route, being the most general, is only going to be selected if all the other potential listed routes, known routes, have been exhausted. And you can see listed to the left in our graphic depicting BGP default routing. You have up in the upper left-hand corner, you see the route to 0000 network is from EIGRP with an administrative distance of 170, and it's coming from our router 4 router in the EIGRP part of our lab. And underneath is the essential configuration that's necessary for that to work. So again, configuring default routing. There's a couple ways to do this in BGP. One is with a static route. As we've stated previously, the IP route 0000 with the mask of 0000, or stated another way, 0000/0. You can use multiple static routes, floating static routes, another with a very high administrative distance. You can also use an existing IGP route, which is what's depicted in the graphic to the left. Make certain that there's a route to the 0000 network, and then you configure the announcement of the default route in BGP. You can do this one of two ways. You can either use the redistribute command, and we're going to cover redistribution in a different lesson, but that's one way to do it. The other is you can use the network command. And if you recall, the network command in BGP announces specific prefixes. So in order to be able to do this with a default route, you just use the network 0000 command under BGP, and then, as in the case with other routing protocols, use the default information originate command under BGP. Make certain, as we've stated previously, that you're using the most optimal location to announce the default route. In our particular case, in BGP, router 1 is the most optimal because that's where the EIGRP domain is, and that's where the route is listed. Verifying default routing is very simple. Show IP route BGP, and it should list the default gateway, the 0000 network. Show IP route 0000 should also list a lot of applicable details. And in addition, you can do show IP BGP, which will list the BGP table, the routing information base, and look for the network, specifically 0000. In addition, you can use ping and trace to some public IP address to verify routing to and routing from the device in question. Route summarization has similarities to some of the IGPs that we've previously discussed, but there are some distinctive aspects in the way BGP actually operates. So we want to look at how route summarization operates in BGP. We're going to start with why do you want to summarize routes? What's the point? Why do it? How to configure summary routes in BGP, and then finally how to verify the existence and the successful configuration of summary routes in the BGP protocol. So the first question is, why summarize routes at all? We've talked about this previously. Optimal routing protocols will summarize whenever possible. And the reason why is because you don't get points for having bigger routing tables. In fact, larger routing tables take more time to process, they require more memory, and they require more CPU cycles. So the smaller a routing table, the more efficient everything can be. So positive aspects of route summarization, as I just mentioned, it shrinks the size of the routing table. It also reduces the scope of the routing table as well. In EIGRP specifically, it will shrink query scopes, and in BGP, it just simply means that the path that's been constructed is going to be shrunk down a little bit. For example, when we talked about BGP path attributes, there was the aggregator attribute and the atomic aggregate attribute, where path information has been lost. Well, when a route is summarized, some of the path information becomes lost. Now, the aggregator attribute points to the router that did the aggregation, but in essence, it shrinks the size of a particular AS path. Summary routes frequently carry the best metric. In BGP, this is just simply a matter of adjustment. These are just some general principles. Again, potential drawbacks, less than optimal routing. And if for some reason the networks that are contained within the summary are not reachable, you're going to have packet discards. Now, as we'll discover later, you have to have at least one route in the routing table that's represented by the summary, but it's not going to check to see if all of the routes that are potentially there are contained in the routing table. So if there's a particular route in the range that's not represented or it's offline, you may end up with packet discards. And pictured to the left is a great example. You've got the 192.168.10 through 15.0 that can be represented by a single prefix, the 192.168.00/20. Configuring summary routes in BGP, the syntax is different than it is in some of the other protocols. For instance, area range and summary address in OSPF, and the summary address per interface in EIGRP. In BGP, it is the aggregate address command. And under the BGP configuration mode, router BGP ASN number, the title aggregate address, the prefix, then whatever the mask is, and I'll explain the summary only command in just a minute. One of the things that the aggregate address command will do is, as a lot with the other routing protocols, it will create a route to null zero, a summary route in BGP. You will see that if you do a show IP route BGP, you will see the route listed, the prefix listed, but it will route to null zero. And that's something you can use for verification later on the originating router. Now, you can have BGP announce the summary in addition to the other routes. For instance, on the left, you could have BGP, for example, announce not just the 192.168.00/20 summary route or aggregate address, but it can also advertise all the other ones as well. When you use the summary only command, it will suppress the more specific prefixes. So for instance, if you configured aggregate address 192.168.00 and then 255.255, so forth for the prefix, then the keyword summary only after that, only the 192.168.00 is going to be advertised. All the rest will be removed from the routing table and suppressed. You can obviously also have a multiple amount of aggregate addresses. For instance, in the ISP that I originally worked for when I started in the business, there was a summary address configured, an aggregate address configured of 216.145.0.0 and then 255.252.0, which essentially was the /19 prefix, which you can still find in the routing tables on the internet. So it just gives you an example of how the aggregate address entry works. You have a number of different commands at your disposal to be able to verify successful configuration of your BGP route summarization. First, show IP route BGP. Remember, this is the show IP route command with the BGP qualifier, so it'll list only the BGP routes. Remember that eBGP routes will have an administrative distance of 20 by default. iBGP routes by default will have an administrative distance of 200. This is just another loop prevention mechanism. It will show all of the routes unless they've been suppressed. That's the aggregate address summary only command. You can also look at the specific prefix with more details with a show IP route and then the specific prefix. To use the example I talked about earlier, going to the AT&T route server, for example, show IP route 216.145.0.0, and it'll list all the details available at the route. It'll say it's a summary, for example, an aggregate address. On the originating router, if you do the show IP route and then the summary prefix, you should see a route to null zero. If you don't, and it's on the originating router, you need to check some other things to make certain it's been configured correctly. And then finally, the Show IP BGP will show you the contents of the routing information base, and you should see the summary in there as well. BGP, as a protocol, has a number of options available for route manipulation. We're going to get into some of those in the next section of this particular lesson, part 2, but we want to look at just the raw type of route filtering that's available, understanding some of the parameters, the specifics of BGP route filtering, how to configure that, and then finally how to verify it. Because verification is always an important part of being able to match configuration with results. So to begin with, filtering BGP routes from the IP routing table, much like with OSPF, essentially you're taking what's in the BGP routing table and preventing it from being installed in the IP routing table. You can use several aspects to do this. One's distribute lists. Frequently, this is just the default way that you can do that. You can have it applied globally to the entire BGP process using the distribute list command under BGP. You can apply it per neighbor using the neighbor IP address, distribute list, and then the access list number or name command. If you want to use access lists for creating distribute lists for BGP, you have to understand that you can use both, and I have listed here, use a standard rather than extended access list. You can actually use both. Standard access lists are going to be a little easier to understand at the CCNP level. But remember, just some general principles about access lists. Always list more specific entries before more general ones. It's the same type of logic of you want to have more specific routes in your IP routing table and then have more general ones catch everything else, like the default route. So keep that in mind. Otherwise, your more general entries could keep your specific entries from being effective if you have them listed after the general route entries. And then obviously, to apply the access list, use the distribute list command, the syntax of which we've already shown you. The syntax underneath is very simple. Access lists, number, name, permit or deny, meaning you're permitting or denying it in the distribute list process. And then the prefix and mask, and then obviously the distribute list, in or out, and the interface that's listed. You can use prefix lists as well. Prefix lists are very powerful because they allow you to be able to match not only a specific prefix itself, but also the length of the prefix. You can use the greater than and less than values to be able to match an entire range of addresses. You could, for example, if you wanted to have everything greater than a /24 filtered out, you could specify that by the prefix, using the greater than, less than, and the right combinations. And actually it's greater than or equal to or less than or equal to. And then you obviously apply the prefix list using the neighbor prefix list command. Route maps actually represent one of the best ways that you can do not only path attribute manipulation, but also route filtering as well. In some of the other protocols, the limitations with route maps are significant, but in BGP it's the opposite. There's a great deal that you can do with route maps. They're used in all routing protocols, but BGP can take advantage of a number of those things. Remember, route maps use sequence lists. So if you had the command from global configuration mode, route map, the name test, permit, and then a sequence number like 10, and then you can, for instance, if you decide later you want a different set of criteria, you could put a route map permit 15 in order to be able to insert it in between. It's just some programming logic. And route maps you can use, there are set and match actions. Match determines the criteria you're going to use. Set is the action that's going to be taken. And for match, you can match IP address, next hop, interface, route metric. When we get to policy-based routing, there's a boatload of stuff you can do. Under BGP, the match can actually not only be the traditional things that we've talked about, but you can also match a specific AS path. You can match a community setting, a path attribute, if you remember we talked about earlier. You can also match tags. And as far as the set actions, you can set the community you want a particular route to be a part of. You can tag certain routes. There's also route dampening, which is beyond the scope of what we're going to be talking about, but it is also an option. And then we're going to be talking more about these different options under the path manipulation section under BGP as part of our lessons. The route map syntax is very simple. Route map, map name, permit or deny, and then the sequence numbers we talked about, the match criteria, the set criteria, and then the neighbor, IP address, route map, the name, and in or out depending on the way you're going to use this. Verifying the route filtering. If you're using an access list with a distribute list, for example, use the show access list command. It will list the number of times that access list has been utilized. If the settings are all 0 and something should be filtered, then something is not correct. Non-zero entries in the counter tells you that something is being matched. You can also use the show IP route BGP and make sure the routes you're expecting to filter out are in fact gone. If you're filtering on all the interfaces, you can just use the show IP protocols command and it'll say outgoing filter list or incoming filter list is set at such and such. For prefix lists, just do the show IP prefix list. Again, look for counters that are non-zero. Also, the show IP route BGP should show you whether or not those routes are absent from the prefix list filtering. And then for route maps, all the same types of syntax will assist you in that regard. So we'll look a little bit again at the AT&T route server so we can kind of get an idea of how these principles that we're talking about apply. So we'll go back to our route server, RVIEWS. And incidentally, this is route-server.ip.att.net. You also see an alternative name as route-server.cbb, which stands for Common Backbone, tier3.att.net. So we're going to do show IP BGP. We've talked a little bit about this before, about some of the things that are in here, but I want to do the show IP route 216.145.0.0. Notice here it's listed and it says SuperNet, which tells you that obviously, since these were in the old nomenclature Class C addresses, these have been aggregated into a single prefix, which is what we've talked about here. The 216.145.0.0/19 has different tags, but this is an aggregated route. Now, if I did show IP route BGP, well, let's do show IP route 216.145.0.0. This is what we just did. Show IP BGP 216.145.0.0. Again, here it says aggregated because this has been put in by the summary address. What you can probably tell, there are no more specific addresses that have been listed, which means that the summary only subcommand has been used in this. You can see a very large numbers of AS paths that are listed. Origin IGP, different community attributes. But these just give you an idea of how the route server command has been used. And let's do show IP route 0.0.0.0. It would always help to type it correctly. Notice here this is a static command. It has been configured obviously by static route and redistributed into BGP. Now, because this is a route server, we do not have the configuration details that we're able to look at because it's been restricted. For instance, if I do show configuration, show running config, it's not going to let me do it. On a router that you have configured, such as what we have in our lab, it's a great deal simpler. So that's one thing that you could do in being able to look at how these summary addresses and such actually operate in a real network. The final consideration in this section of our lesson is going to concern the whole concept of BGP peer groups. Peer groups actually allow you to aggregate not addresses, but actually configuration information for a large number of peers. It's a way of being able to shorten configuration sizes and complexity. So we want to understand a little bit of how peer groups operate, what they are, what they do, how to configure them in BGP, and then how to verify successful configuration of peer groups. This is one aspect we will not be configuring in our lab, but I did want to list it as a common way of being able to use configuration commands for BGP. So peer groups allow you to consolidate large-scale configuration requirements. For instance, when we have looked at the AT&T route server, if we do show IP BGP summary or show IP BGP neighbors, there are a large number of neighbors. BGP peer groups can actually help consolidate the requirements for being able to have common configuration elements and fewer configuration commands to make it happen. There's just an example of some things that you can put in a peer group entry. If there's a configuration that has password requirements, the MD5 authentication between neighbors, you can have that there. if you have common community settings. If you want to use, for example, the loopback interface as the update source, you can use that in the peer group configuration. If you have eBGP multi-hop requirements, you can have that in there. Timer specifications. If you have neighbor filtering statements that are common to all the devices. And then finally, soft reset configuration inbound, for example, ways to be able to put that into the configuration command set. Configuring peer groups are actually very simple. You enter BGP configuration mode, for instance, router BGP 65001 if we were using router 1. You create the peer group with the neighbor, the name of the peer group. For instance, if you wanted to call it ebgp-peer-group, that would be the name. Then subsequent commands, you use the peer group name settings command. For instance, we talked about password or update source or multi-hop and so forth. You'd put that under the neighbor peer group name and settings command. And then finally, when all that's done, to be able to apply the peer group to a neighbor or neighbors, then you would use the neighbor peer group, the name command under BGP. And then it would take all the settings configured for that peer group and applying that to that particular router and neighbor relationship. For instance, if you had a specific set of policies you wanted to have for all the eBGP neighbors for a particular router, you could have an eBGP peer group name. And if you wanted a different set of policies for iBGP routers within the autonomous system, you could have another peer group name. This is just a way to be able to configure it. To verify that peer groups are configured and working correctly, you can use the peer group name, show IP BGP peer group name command. And then obviously if you use the show running configuration command, it enables you to view the configured peer group settings on that particular device. Let's look at some of the terms we talked about in this particular lesson. MD5, remember that's the message digest algorithm version 5. It's a hash function that creates a 128-bit hash value and used by BGP to authenticate neighbor messages, much as it has been in EIGRP and OSPF. Route summarization is the process of taking a larger number of contiguous networks and expressing them in a reduced form. Remember the 192.168.1.0 through the 15.0 being able to be summarized in a single aspect. Route filtering is the process of removing routes selectively from the routing table or a routing process. ASPath prepending, which we just mentioned sort of in passing, is manually configuring a longer ASPath attribute for certain routes or paths to make them less desirable. Remember in BGP, shorter ASPath is preferred over a longer ASPath. Prefix list is similar to access lists in terms of filtering, but with the ability to specify prefix and mask to be able to cover a number range of addresses. And then peer groups are a common set of configuration parameters for BGP for a group of eBGP or iBGP speakers. So what did we go over? We covered BGP authentication between neighbors, default routes, route summarization using the aggregate address command, which could include no summary to suppress addresses, more specific, route filtering functionality, and BGP peer groups. We have much more to cover in BGP in our next lesson, and we'll look forward to talking to you then.